All right, ready to roll with our one more relook one last time at some of our issues from our Trig 1 quiz. Reminder, this entire packet needs to be done in its entirety using the rules that we're doing in order to be eligible for the retake tomorrow. Again, this packet is done tomorrow or no retake is available. Okay, now that we've got that straight. All right, up here at the top, use the given point to determine if the triangle formed is a 30, 60, 90, or 45, 45, 90. Then use your knowledge of angles to determine the measure of the requested angle. Hint, use a different color pen to mark the sides before you start and solve for x, then just substitute. Also notice it says use trig rules and not a protractor. You cannot just slap your protractor down, give me a measurement, and say, woo, I'm good. Not good. So, a couple of things that could be helpful to us on this page, which will be available when we're doing this on the retake. But for now, we'll go ahead, we'll get these back in. Again, on a 45, 45, 90, my 45 sides are the x value. That's going to be my x square root of 2. And when I'm looking at a 30, 60, 90, my 30 side is the x. My 60 side is the x square root of 3. And my hypotenuse is going to be 2x. Okay? Those are critical when I'm working through these. So, here's a few of the things I've got to keep in mind. When I'm making these triangles, okay, when I'm trying to figure this part out, you're always connecting back to the x-axis. You do not have a choice here. You cannot go to the y, you can't back to the x. Then to figure out the rest, remember, this is an x and a y value. So my x value along the x-axis is -3. My y value, going the same direction as my y-axis, is +3. So you're like, well, how do I figure out if it's a 45, 45, 90, or 30, 60, 90? Pretty simple. On a 30, 60, 90, one of these two sides would be square root of 3. I don't see any square root of 3. So this is going to be a 45, 45, 90. And actually the rest of this should be pretty simple. So here's how this would work. So I start here and I'm going clockwise. Okay? If I'm going clockwise, that's going to be a negative angle, going clockwise. So I know my answer is going to be negative. What else? Well, I also know if I label my axes as I'm going through clockwise, I notice I go past the 90. So far here I've got -90. And then I come up and I got another -90, or I could have just said -180, I guess. And then here, if I'm trying to get to this line, it looks like I've got another 45. So I just add those three up, and I get my angle measure. Okay. But again, you've got to take it in pieces, and we also got to keep in mind when we're going the different directions that changes the value of what I have on the axes, but it's nothing different from what we've done before. Okay. So if I'm looking at the second one, and again, we'll just kind of keep repeating. We're going to do this whole first page together, so I want to make sure you've got this down. So I look, and I'm like, okay, make my triangle here. Again, I notice this time there's a square root of 3 involved. So my x is 2, my y is 2 square root of 3. Again, the x value goes parallel to the x-axis, the y value goes parallel to the y. And again, this isn't going to be too hard because I go, okay, well, the 2 square root of 3, okay, the square root of 3 side is always opposite my 60. So that's got to be my 60, which makes this guy my 30. So again, I go and I notice, again, we're going clockwise. So it's going to be negative. If I go ahead and label my axes as I go around, I notice I get all the way around to here. So that's negative 270. Now this time I got to be careful. I've got 90 degrees left here, but 60 is taken up by my triangle. But the part of the angle I want isn't in the triangle, so I don't want the 60. I want this piece that's left right here. So if this quadrant, because every quadrant's worth 90, if this is 90 and that part's worth 60, it means the piece that I'm missing right here is 30. And since we're going clockwise, it's negative. That's why I'm putting the minus on there. And I can get my angle measure. That's why it's nice to label these, so I can see how much I already have and what I have to calculate left based on the angle measure that I've got. So if I move up, okay, same thing going on. Back to the x-axis. This is my x and my y. So x and y. Ooh, there's a square root of 3, so I know it's a 30, 60, 90. The 60 is always opposite. Okay. And this 30 is always going to be opposite my one that doesn't have the square root. So again, I look. Again, I'm going clockwise, so I know it's negative. So I'll go ahead and label these. So what do I know? I know my answer's got to be between 90 and 180 because that's the quadrant I'm in. So I take a look and I go, okay, I got negative 90 here. Now, do I want the 60? No. Okay, this is 90 degrees worth. The angle that I have is 60. I want this piece. 90 minus 60 is 30. And I've got it. Now again, if I wanted to use my protractor to double check, sure. That wouldn't be a terrible thing. But just to write it down as normal, that's not going to work. Okay, so then the last one we're going to do together is going to be this last one on the front page. Again, back to the x-axis. There's my x and y. This time I notice no square root of 3, so it's not a 30, 60, 90. It has to be a 45, 45, 90. But for the first time, though, now it's going counterclockwise. So if it goes counterclockwise, that's going to be a positive angle. So I look and I go, okay, here's where it starts. I'm going to label. So I go, okay, so here we go. We got 90. Each stop, I'm going to even name off where I'm at. 180, 270. So I got 270 so far. But I got to get this little piece still. Whole thing's 90. 45 is missing. I need this part, which would be 45. Okay, so again, label your axes. The right triangles, okay, the patterns will be up on the board. So all you've got to remember is, ooh, if it has square root of 3, it's 30, 60, 90, and make sure you don't get those mixed up. And if there's no square root of 3, it's a 45, 45, 90. And I'm set with that. But again, practice those, check them against the key in front, make sure you're getting the hang of this. And that way, if we got to answer a few questions tomorrow before the quiz, we can do that. Okay, so the back of that page is all you. So next part. Solve each problem. Draw your own pictures, okay? I'm going to give you a situation, so like on number 1. Draw this nice and big here. So we've got a 30, 60, 90 triangle. Okay. If the side opposite the 60-degree angle is 12, then what is the length of the side opposite 30? Now here's what I want you to do with the different color that you should have picked up on the way in. I want you to actually go and label the sides with their correct measures, and here's what I mean. I want you to do this in a different color. Opposite of 30 is x, opposite of 60 is x square root of 3, and my hypotenuse is 2x. Now you go back and you say, okay, I got to do some algebra. Where's the side? I have a number here. Okay, so I'm going to do an algebra equation. X square root of 3 equals 12. So I go ahead and I solve this for x. Now remember, I can't leave a radical in the denominator. That's not allowed. So I go ahead, I get this situated, I rationalize my denominator. Again, outside a radical and inside, I can't multiply those together, but I can do it with these. 3 square root of 9, which is 3, but don't get lazy. Okay, those numbers that are outside the radical, if I can reduce them, I can. 12 divided by 3 is 4. So 4 square root of 3 is the x value. Now what does that mean to me? That means to me, everywhere I go around, this is 4 square root of 3. Okay, there's the answer I wanted, but I'm going to do the rest of them just to make sure. Here, if I wanted the hypotenuse, I'd take the 2 and I'd multiply it by 4 square root of 3, which would be 8 square root of 3. And I get my answers that way. So you can see how having this in, I'm literally solving for x and then substituting is all I'm doing to get that value, to get that answer. Sometimes it'll be really easy. Sometimes this is about as much work as you'd have to do on any of them. Now again, let's kind of peek at some different ones here. We're going to go down to 4 and see some other situations that could pop up. And where you put your 30 and 60 don't matter as long as you get them into the right spots with your pattern. Okay, the side opposite the 30 degree is 4 square root of 3. What is the length? Ooh, I'm supposed to find the 60 and the 90. Okay. So opposite of this, 30 is x. Opposite my 60 is x square root of 3. And my hypotenuse is 2x. Again, I would use a different color for that, just so it stands out to me on what everything's going. Find the side that has the number here. X equals 4 square root of 3. Ooh, I don't even have to solve anything. That's what x is. So what's that mean to me? Okay, what that means is when I come here, x is replaced by this value. So 4 square root of 3 times the square root of 3. Okay, I have to figure this part out. So square root of 3 times square root of 3 would be square root of 9. And the square root of 9 is 3. Okay, so this side is 12. Notice how it's straight substitution and simplify. Here, 2 times x. 2 times 4 square root of 3. 2 times 4 is 8. Leave the square root of 3 alone. I've got the two sides that I'm being asked for. Again, just take your time. The values will be there. You've just got to do the algebra part. But you've got to keep working at it and keep trying it. You might have to watch this later again if something's still not clicking. Just give yourself that shot. Okay, we're over to 6. We've got a 30, 60, 90 still. Okay, at the side opposite the 90, my hypotenuse is 6 square root of 3. What's the length of the side opposite the 30 and the 90? Okay, again, 30 is x, 60 is x square root of 3. This is 2x. I pause. I go, okay, where's the number value I have? It's this side. Do my algebra part. Okay, to get x alone, I got to divide by 2. Now, this one's not going to get ugly. So wherever I see an x now in red, I'm going to substitute this value in. So here, x is 3 square root of 3. Okay, that's that side. I'm done. But that side. Over here, I replace the x with 3 square root of 3. Whoops, if I'm on the screen here. And I replace, okay, the other square root of 3 still here. Square root of 3 times square root of 3 is square root of 9. You're like, wait a minute, that's 3 though. Okay. That side's 9. I'm done. One-step algebra and some simple substitution. You've got this. I know it's weird. It's weird from normal equations, but that's really all it is. All right, finally to 45, 45, 90s here. All right, so 45, 45, 90. If the side opposite the 45-degree angle to 45, 45, 90 is 12 centimeters, you're like, wait, there's two 45s. How do I know which one? Remember, x square root of 2. They're the same thing. So I'm telling you that both of these sides are 12. There's only one thing you got to find. What's the length of the side opposite the 90? But I know already x equals 12 because that's what the 45 side is. So to get this side, I just plug in the 12 for the x. 12 square root of 2. I'm done. Don't make life difficult on yourself. You can do this. Just take your time and plug the values in. Okay. I think we got a couple more over here on this side. And then I'm going to let you loose here. Well, not let you loose. Still got to look at some right triangle trig apps. Okay. So 45, 45, 90, x square root of 2. Okay, side opposite the 90, my hypotenuse is 12 centimeters. Okay, what's my other one going to be? Again, got to do some algebra this time. This one, going to take a little work, because to get x alone, we're dividing by a square root. We know that when we divide by a square root, we've got to rationalize it. We have to simplify it. Now, if you remember our little rule from before, which I'll talk about once we simplify it, this can go a little faster, but it's not a necessity. Okay. Both radicals, multiply what's underneath. Square root of 4 is 2. So I get this. Now, if you remember back to our rule, we said if the hypotenuse in a 45, 45, 90 is a whole number, you just divide it by 2. 12 divided by 2 is 6, and slap a square root of 2 on it. That still works. But otherwise, I just have to do this, which means both of these sides are just 6 square root of 2, because that's what x is. I'm done. Keep life simple. Okay. One last special right triangle trig here. All right, side opposite the 90 is 16 square root of 2. Again, label your sides. Makes life so much simpler. Find the side with the value. Do any algebra if you have to. So those are equal to each other, and since I'm trying to get x by itself, I'm going to divide by the square root of 2, but this time it's nice. It just goes away. And since my 45 sides are just what x is, I've got those two already and I'm done. Okay. So the rest of these you're going to be on your own for as far as those go. Again, we did like half of them, so you've got the other half to knock out. Okay, last thing, little right triangle trig here. So when we get here to the back, all right, so as we look at our applications, reminder, the three trig functions that we're using, sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. So we've got a ladder leaning against a building. The ladder is 10 meters long, and it's sitting on the ground 4 meters out from the building. What is the angle the ladder is making with the ground? So, what sides do I have? Well, the easiest side always defines opposite the right angle, my hypotenuse. The angle that I'm looking for, if I go across, would be the opposite, which means the side that I have left is the adjacent. So when I'm looking for an angle, remember, I have adjacent and hypotenuse, so it's going to be cosine. But also remember that this is the one where we take the inverse. Now, one other thing to keep track of, because classes are getting into using different things. When you go to mode on the calculator, make sure you're in degree. If not, your answers are going to be messed up. Cosine, the little -1's there to remind me that I hit second in cosine when I'm doing angles. That's where the little -1 comes from. 4 divided by 10. And we'll go to the nearest whole degree here and just work it that way. So again, nothing too bad. So I come down a little further. I go, okay, after a windstorm, one of the hydro poles has a lean to it. The poles are 14 meters high. So again, the 14 is just labeling this. And the angle between the pole and the ground is 81. How high is the top of the pole above the ground? Again, label your sides. Opposite the right angle is my hypotenuse. Opposite my angle is my opposite and leaves me my adjacent. So what values do I have? I have opposite and hypotenuse, which is sine, but I have the angle this time. And again, you have to do them in the order they're on the sheet. It's opposite over hypotenuse. If you do it the other way, you're not going to get the right answer. And we've said before, if the x is on top, we're going to multiply times our trig function. And typically with these, we go to the nearest tenth. If you just want to go to the nearest tenth with everything, that's probably not a terrible idea. Okay? We can get our value. Okay, no second when we're looking for sides. Get over here to the back. This is the last one we're going to take care of together. All right, we got to draw a picture this time. But we know all of these are going to end up being right triangles. So a 6.1 meter ladder leans against a wall. Okay, leans against the wall. Here's my ladder if you want to. There, make it look more like a ladder. The angle formed by the ladder and the ground is 71 degrees. I got to pay attention to little words like that. And the ground tells me it's down at the bottom, not up here at the top. So, part A. How far is the foot of the ladder from the wall? Okay, we'll call this X this first time we go through. What sides do I have? Well, let's see. Hypotenuse, opposite, adjacent. That's why I like using the different colors. So I have adjacent and hypotenuse. Which trig function is that? Cosine. So cosine of 71 is adjacent over hypotenuse. So again, if the x is on top, we multiply by the trig function. If it's on the bottom, we divide. So this is going to be 6.1 times the cosine of 71. And I always want to make sure that my answers seem kind of sensible, because sometimes that can even let me in when I've done something a little screwball. So here, oh, that's going to round up. So round up to, oops, we're not talking in feet, Harty, meters. We're going European here. Okay, so that's my first part. Then my second part says, how high up the wall does the ladder reach? Okay, I'm going to call this Y. Yo, no, just kidding. We're going to call this Y just so it's something different to look at. So I look, my sides are still all the same. So this time I've got opposite in hypotenuse, which would be sine. But once again, variables on top. But you see how it's important that I labeled correctly, because otherwise I'd have gotten these backwards and I'd have ended up getting both of them wrong. That's no good. So about 5.8 meters. Okay, I'm going to say this one more time. The rest of this packet, done well with work shown tomorrow when you come in to be able to get your retake option and get those points back. And there's nobody that can't afford to have some extra points right now. So please make sure this is ready. We're going to do this in a little bit more of 13.1, and we'll see you then.